Let's move it up a notch. Let's factor a quadratic expression that looks like this. But in this case, the coefficient of x squared, this a, is not going to be 1. Now here's an example. We have a trinomial here, and the coefficient of x squared is 2. Now to begin to factor this, we first decide, do we have a common factor? And as you can see, the first two terms have an x in common. The constant term does not, so there's no x factor in common. And 2, 7, and 6 don't have a factor in common other than 1. All right, so there's not a common factor within the three terms. Step 2 is to see if we can factor this using reverse FOIL as a binomial times a binomial. And because the coefficient of x squared is not a 1, as we mentioned before, we're going to have more possibilities to check in order to come up with our answer. So we start with the coefficient of x squared, which is 2. What are the different pairs of numbers that multiply to 2? And we have 2 and 1. Now we could list 1 and 2 also, but in the first position, this is sufficient. So I'm going to start by writing 2x in the first position, 1x in the second position, and as you can see, 2x times 1x is 2x squared. Next, take a look at the constant term 6 and list all the different pairs of numbers that multiply to 6. We have 1 and 6, and what we'll do is we'll start with 1 and count up to 6 for our possibilities. We have 2 times 3 is 6. We have 3 times 2 is 6. 4 and 5 don't divide into 6. And finally we have 6 times 1 is 6. Notice 2 and 3 and 3 and 2 were listed separately. 1 and 6 and 6 and 1 were also both listed. The reason for this is I'm going to check each one of these pairs in this expression. And if I put a 1 here and a 6 here, when I get the outer product, 6 times 2x, I get 12x. When I check 6 and 1, if I put 6 here and 1 here, 1 times 2x for the outer term is 2x. So I'm going to end up with different results. Therefore, I have to test each pair in both orders. So let's start with 1 and 6. I'm going to take the 1, put it here, the 6, put it here, and I have 2x plus 1, and I have x plus 6, and check by FOIL. 2x times x is 2x squared, 2x times 6 gives me 12x, the inner is 1x, and 1 times 6 gives me 6. And I noticed that the 2x squared and the plus 6, they're just fine. The middle term is usually where all the work is. 12x plus 1x gives me 13x, not 7x. Therefore, this pair doesn't work. Let's try the next pair, 2 and 3. So I copy my expression over again. And I have 2x plus 2. And I have x plus 3. And we FOIL it once again. 2x times x is 2x squared. 2x times 3 is 6x. The inner is 2x. And 2 times 3 gives me 6. And the 2x squared and the 6 are fine. How about the middle term? 6x plus 2x gives me 8x. The middle term, 7x, this pair doesn't work. So I cross it out. Let's check our next pair. We have 3 and 2. So I have 2x plus 3. And we have x plus 2. And we run through FOIL once again. 2x times x is 2x squared. 2 times 2 gives me 4x. 3 times x is 3x. 3 times 2 is 6. And the 2x squared and the 6 are fine. How about the middle term? 4x plus 3x gives me the 7x I'm looking for, and I have my pair of numbers, 3 and 2. And I enter them into this expression in that exact order. Remember, the 2 and the 3 did not check. 3 and 2 did. The 3 goes in the first position because it's first, and the 2 goes in the second position here. And we have our answer. We're finished. What I would like you to do is try one. So let's see you factor the following using the same procedure. 3x squared plus 7x plus 2. Please pause the video. When you come up with your answer, turn the video back on and we'll run through it.